Okay, let's go ahead and try some multiplications. Well, we have the rule that I gave you before. The sum of the logs is equal to the log of the product, right? And we can go ahead and use that rule to do multiplication simply by addition. And what we have to do is be able to take logarithms. I'm going to be really explicit about this and then show you how to speed up the process. Let's say we want to multiply 2 by 1.5. I would go and get my 2 over here, right? And if I look up on my mantissa scale, my L scale, I find that it's approximately 0.3. I'm going to go ahead and slide this over so that 0 is lined up with the cursor, right there. And I'm going to use my C scale and go get the logarithm of 1.5, right? Well, here's what the logarithm of 1.5 would be. It's like 0.176, it looks like. And I'll go back over here and reposition the slide so that it's lined up there, right, with where I began. So the sum of those two distances should come out to 0.477, it looks like. 0.477. Now 0.477 is, or should be, the logarithm of 2 times 1.5. And so if I want to undo that logarithm, right, I read from the mantissa scale back onto the C scale, and I find 3, which is 2 times 1.5. Right, to speed up the process, I don't even have to worry about the mantissa scale. Just know that it's there, and that's why this is always going to work. What I do is I line up my index with the first number I'm multiplying, the 2, right there. And then on my other scale, right, I'm adding this distance of 2 on this D scale. On my other scale, I get the distance 1.5, right there. And look back down on the D scale, sum of the two distances is 3. Right, if I wanted to multiply 2 times 2, I get 4. If I wanted to multiply 2 times 2.5, I get 5. 2 times 3, I get 6, and so on. Works all the way down before any decimals, up to about an accuracy of 3 digits. Now, what if we want to do something like multiply 7.8 times 8.9? Well, that presents a little bit of a problem, all right, because I can't line up my right-hand index with the 7.8 over here and get a reading for 8.9. What I can do is move this slide over, right? I'll line up the cursor so I can see where I'm going. There's 7.8. Line up that index with the 7.8. And because these scales would repeat, right, if I had a really long slide rule and things just kept on going on, the scales would repeat over and over again, except this would represent 10, the next one would represent 100, and so on. So I have that lined up with the 7.8, and I go and get my 8.9 and look underneath, and that should be the product of the two numbers. Looks like 6, 9, 2, I'd say. Well, I know 7 times 8 is somewhere in the, about around 60. So 69.2. I'll go with that. Alright, well, what about the situation where you might say, okay, if I got to multiply 1.7 times 9.2. Well, okay, I'll get my 1.7 lined up with the index there. And I go to get my 9.2, but I find that it's way off the scale here. Well, the other option is to move the slide back and get my index over here lined up with the 9.2 and hope the other thing lines up on the other end. What's quicker than that is using two scales called the CF and DF scales. You find them right up here. What these are, DF is for folded. They're exactly the same measure as the C and D scale, except that the index is located right here in the middle of the slide rule rather than on either end. Right? And because we have those symmetries I was talking about before, right, we get our 1.7, and I said I wanted to multiply that by 9.2. Well, I would have been looking for 9.2 up on the slide here. I can still get it. Well, it's right over here. 9.2 should line up just like that. And I can look up on this scale right up top here, and I see 1, 5. That looks like 1, 5, 6. Alright, so I'll say about 15.6 or 1.5 times 9.2. And that should be about the right order of magnitude. And that just about covers all the different possibilities with multiplication and different issues that you're going to run into. Alright, it doesn't matter if you're multiplying 3.14 or 314, you're going to get the same set of numbers, just the decimal will be at a different point. So it lends itself very well to scientific notation. Just have to keep track of the magnitude and let the slide rule do the work of multiplying out the numbers. And that's that.